You can write it as 119 or 121. So anyway, you will get marks for this. And next one, again, N2, in the case of N2, we have a lone pair. Because of the presence of this lone pair, the bond angle may be 118. Again, plus or minus 1, you will get marks. But anyway, it is better if you mention that as 180. 118. So it's correct. And next one in 3. In 3, we can compare the bond angle of this with the water. Normally, if you have two lone pairs and two bond pairs, in the case of water, it is 104. So this may be around 104. And the other one may be 108. This is exactly linear. So 108, 104 and 180. Yeah, that's correct. All four correct. So 1 into 4, you will get number 4 marks. And arrange the atoms in 2, 3, 4, increase in order of the electronegativities. So how? First, I will get copied it. And see what we can do with that. This is the structure. So here you have to consider about the hybridization, carbon nitrogen onto only the nitrogen, right? Nitrogen into N3 N4. Hybridization into hybridization of N2 is sp2. Is P2. And N3 is P3. And the other one is P. Then the charge. Here 0, no charge. Here -1 and here +1. Then obviously now you can find it. sp hybrid nitrogen will have the highest electronegativity. sp3 will have the least. And also if you get the charges, charge is minus here. Okay. Charge of this N3 is minus. Therefore, the N4 has the highest and N3 has the least. So N4, N3, N2 will be an intermediate. That's correct. So 2 marks for that. That is about the part B and the part C now. First one, arrange the species in the increase in order of the property indicated in the parentheses. So calcium, chloride, bromide, iodide, ionic character. Yeah. Ionic character mainly depend on we can explain the ionic character using different methods, so different theories, but here I am going to use the polarizing power and the polarizability. Polarizing power of the cation and polarizability of the anion. In this case, you can say that all the cations, in all the compounds, the cation is common, calcium 2 plus. Therefore, the effect on the anion will be same. So you can say the cation is common. Cation is common. Cation is common means it is calcium 2 plus. Then the charge of the anion is also common, no same. Charge of anion is same. It is -1. But the size of the anion increases from F minus to I minus. F minus, Br minus, F minus, L minus, Br minus, and I minus. So you better to write it in this way. F Cl minus, Br minus, and I minus. Because of the increase in size, what happens? The polarizability increases in the same way. Therefore, polarizability increases in the same way. F minus to I minus, F minus L minus Br minus Ni minus. When the polarizability is higher, the polarizability, higher the covalent character. Therefore, the ionic character decreases in this direction, and sorry, the ionic character now will decrease in this direction. Why? The iodine is the biggest. When iodine is the biggest, it has the highest polarizability. Therefore, it will have the highest covalent character. Therefore, yeah, the ionic character increases in your way. Ionic character increases as calcium iodide, calcium bromide, calcium chloride, and calcium fluoride. Remember that calcium chloride will not much dissolved in water because of it has higher covalent, iodide, like this. So, this way. So yours is correct here. Next one, the bond angle. Let's see the bond angle here. The bond angle is like this. You have to draw the structures here, ClF5, 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 one lone pair. So F like this, maybe nearly 90 degree. One lone pair and 5 bonds, nearly around 90 degree. Why? Like this. This is square plane and this is perpendicular that, so nearly 90 degree. And ClF2 plus and ClF2 minus, ClF2 plus. ClF2 plus means we have 7 electrons around this chlorine. Plus means it will remove an electron, then we have 6 electron, and because of 2 bonds, it will contribute another 2 bonds and 2 lone pairs will be available. Here fluorine, and we have 2 lone pairs and a pass charge. So the bond angle must definitely be less than 109. The bond angle is less than 109.5. Maybe around 105, 105, 6. Or even, no. The bond angle must be definitely less than 104. That means water. Water has 104. So this bond angle must be less than 104 because the central atom is bigger, and also the electrons are much closer to the fluorine, not to the chlorine. Therefore, the repulsion between these bond pairs will be less. So bond angle must be definitely less than 104. Maybe 102 with it. So it's a very small bond angle. So, and when we get that Cl, so F2 minus, chlorine has 7 electron. Minus means it will get 1 more electron. So it will be now linear. Why? We have 3 lone pairs like this. And if it will be minus. So the bond angle may be 180. More from fluorine. And therefore, the bond angle is highest in this case, not in this case. Understood? ClF5, ClF2 plus, and ClF2 minus. So that is the increasing out of the bond angle. Right. Ionic radius. In this case, what we do here is we arrange the sodium plus. Sodium plus is isoelectronic with neon. Then S2 minus isoelectronic with argon. Cl minus isoelectronic with argon. And potassium plus will be isoelectronic with argon. When something, or when the ions are isoelectronic, higher the positive charge, smaller its size. Higher the negative, it is the biggest. In this case, S2 minus will be the biggest and K plus will be the smallest. And when we compare this neon and argon is definitely bigger than neon because argon is below to neon. Therefore, sodium plus is the smallest and S2 minus is the biggest. Then the order will be sodium plus, then potassium plus, then Cl minus, and then S2 minus. So that is the correct order with reason. Right. And finally, now we have 2 more. Right, next. Carbon monoxide, carbonate ion, bicarbonate, H2CO means formaldehyde and C3OH. Bond length. Bond length depends on bond length. Bond length depend on bond order. Then you need to know what bond order is. Bond order equals number of bonds divided by number of sigma bonds. Then you need to know what this number of bond and number of sigma bonds. Number of bonds means number of bonds between the considered atom. In this case, we need to consider carbon and oxygen. So all the bonds in between carbon and oxygen has to be considered. So if you get like this, right, you have carbon, oxygen, and hydrogen and hydrogen. In this case, you have only a double bond. Carbon and oxygen double bond. No need to consider about this carbon and hydrogen. Why? We need only the carbon and oxygen. So we have two bonds here and one sigma bond. The bond order is 2 divided by 1 equals 2. Right? So then we will do this. So carbon monoxide. Carbon monoxide, the structure is this is the structure. So it has a triple bond. So bond order will be 3 divided by 1 equals 3. The bond order is 3. Then carbonate ion. CO, O minus and O minus. We know that this is a double bond and these two are single bonds. Then single bonds may be much longer than the double bond. But anyway, when we find the bond order, now we have to consider all three oxygen atoms, right? All are connected to the carbon, oxygen, and half. So this has 1, 2, 3, 4, 4 bonds. So bond order will be 4 divided by 3, 1.1. 1.33. No, is 1.33. So bond order is 1.33. Next one, the HCO2 minus. In this case, oxygen O minus, OH and O minus. Here. Then again, you have to consider 1, 2, 3 bonds. 1, 2, 3 bonds. Again, 3 CO bonds. That means we have 4 bonds divided by 3 equal 1.33. And next one is H2CO. H2CO is formaldehyde. Here we have a double bond, so 2 divided by 1 equals 2. And finally, the CH3 OH. Here you have just a single bond, so 1 divided by 1. Remember that higher the bond order, shorter the bond length. That means bond length decreases with the bond order. Bond length decreases with bond order. right. In this case, carbon monoxide may have the highest bond order, right? Carbon monoxide will have the shortest bond length. Carbon monoxide is the shortest. Next, this has 1.33 and also this has 1.33. So the electronegativity is the relative ability to attract more electrons. So when we compare or get these two, here 1.33, 1.33. But when we get this formaldehyde, it has the bond order 2. Therefore, definitely the next one must be this. Next one. Now we have this and this. So in this case, the bond order is 1 means the longest bond length. So this has greater value than 1. So now you have to distinguish which has the higher from this carbonate to bicarbonate. Now in the case of bicarbonate, it has two negative charges. Because of the high number of negative charges, the repulsion between the electron around the carbon and this charge may be higher, therefore it will expand. Right? Therefore, this carbonate will have a bigger value than bicarbonate. So here HCO3 minus, then the carbon, like this CO 3, 2 minus, and finally the CH3OH, because it has just a single bond between carbon and oxygen. Therefore, so this is the correct increase in order. First ionization energy of lithium, nitrogen, chlorine, magnesium, and phosphorus. If you know the numbers, it's okay. You can easily find it. But among all the elements here, the first ionization energy is least in the case of this lithium, maybe. No, we can easily find the biggest or the highest. Highest is for this fluorine. Fluorine will have the highest. Why? The first ionization energy may be varies like this one, second group, third group, fourth group, fifth group, sixth group, seventh group, 8. Right. Then next period, you will have the same pattern, but with less energy. Right. Then here, now you can write the element in the relative positions of lithium, then no beryllium, no sodium, but we have the magnesium. Then magnesium, aluminium, silicon, phosphorus. And here sulfur here. Right. 1, 2, 3, 4. We have 1, 2, 3, 4, 5. By the next element, it is nitrogen. Nitrogen is just about the chlorine. So definitely this nitrogen will have higher value than phosphorus. So here, magnesium, lithium, when we compare this magnesium and lithium, lithium has the lowest. It is around 520 moles per dm³. Magnesium is around 737. Now, therefore, this lithium will have the smallest value. Lithium may have the smallest first ionization energy among all the elements. So it is lithium. And obviously that highest is for carbon, the fluorine. Then magnesium, phosphorus, and nitrogen. Magnesium, phosphorus, and nitrogen. Because in exam we don't know the numbers, right? Remember that. You don't know the numbers. But anyway, the lithium and magnesium, I hope that you need to know that. But anyway, when we get that the other three, magnesium, nitrogen, and phosphorus, then nitrogen must have a higher value than phosphorus definitely because nitrogen is just about the phosphorus. Right? So nitrogen will be the next element. And now we need to distinguish for these the values of this chlorine and magnesium, sorry, the phosphorus and magnesium. Then phosphorus may have the higher value than this magnesium. Therefore, the correct word is lithium, magnesium, phosphorus, nitrogen, and chlorine. Okay. This is the correct order.